simple harmonic motion with a pendulum, a string with a mass on the end swinging backwards and forwards. Yeah, that one's pretty okay for most of my students, but the one that causes trouble is when you've got a spring and a mass on it. So draw a diagram. Draw your spring, draw your mass. So how are we going to get this thing doing a simple motion, but harmonic? One motion making the next motion yeah, you pull it down. Pull the string down, the spring down. You get a tension in the spring, a force going up. When the mass is at its lowest point, it's got velocity 0, because, you know, I'm holding it, and then it goes boing, boing, and then the downwards velocity and the upwards velocity, it's 0 at the bottom. When it's 0, though, just like the pendulum that goes backwards and forwards, here it's 0, here it's 0, there's loads of force, loads of acceleration. In the middle, when it's going fastest, no force on it, no acceleration. Deceleration, deceleration. Same with the spring. 0 velocity, but lots of force because there's lots of tension. F equals ma. The force will make an acceleration. Let it go. Faster, faster, faster. It gets to a point where the gravity equals to the tension, and therefore it adds the maximum speed there. And then higher up, the gravity is beating the tension because, you know, tension gets less and less as the spring gets shorter. And that's the diagram you should draw to get the simple harmonic motion of a mass spring gravity combination.